All right, here are solutions for quiz 4 for Math 213. We are dealing with a 73-sided shape, this heptacontagon, whatever. We're dealing with this shape right here, and specifically a prism that has this shape as its top and its bottom. And you're asked how many vertices does this thing have? Well, your answer here will be 73 times 2, which is 146. Where that comes from is kind of 73 on the bottom and 73 more on top. It doesn't have to have that orientation, but when I think of a prism, I kind of think about this shape on the bottom and then the shape up top, and everything's connected. So that would be the number of vertices I would have. What about how many edges does this thing have? Well, that one's a little bit tricky, at least I think it is. The answer is going to end up being 73 times 3, I believe, which is 219. And you can kind of think about that as 73 on the top and the bottom, and 73 more connecting the 73 vertices from top to bottom. So again, I'm going to think about that orientation top and bottom, although that's kind of subjective. I got 73 going around the top of this thing, so I guess I could kind of draw it for you. Here's your shape, that's 73 sides, and then it goes up this way, and you have these 73 going up this way to your shape, and you got it again up here. And sure, we can pretend that's 73. So I know that I have 73 going across the top here because it's a 73-sided shape. And then I got 73 on the bottom, but I also have to connect each one on the top to one up on the bottom. So there's 73 more. How many faces does this thing have? Well, this one's a little bit tricky, I think. I think it's going to have 75. And the way I'm coming up with 75 faces is 73 around, that doesn't say around, jeez, around the outside. So one face, 2, 3, 4, 5, 6, 7, 73 going around the outside plus top and bottom. So 75 faces. Put that parenthetically, I guess. And I'm just going to give you a little note here. Note that faces plus vertices would be, what, 146 plus 75 more, which is 221, which is 2 more than edges. That's 219. And that's Euler's characteristic or Euler's formula that we talked about in class. That'll always be true. So it's a nice little check for your answer, and in case you didn't have Euler's formula memorized, you're going to want it for the next part. You kind of get into it here. Faces plus vertices is always equal to 2 more than edges. So you get this formula right here. And if you have this formula, it makes this next problem really easy to answer. How many faces does a convex polyhedron, the criteria for Euler's formula? How many faces does a convex polyhedron with, how many faces with this many faces? Bummer. How many faces with this many, what should we make this, vertices maybe? No, how about this? How many vertices does a convex polyhedron with 100 faces and 220 edges have? Well, let's see. If it's got 100 faces, and I don't know how many vertices, but I do know that it has 220 edges, I can just solve this equation right here. I got 100 plus v equals 222, and therefore v is equal to 122. Remember to change that so I don't ask you how many faces and give you how many faces. It's got 122 vertices. Okay, this next page we're moving on to a new topic. We're talking about converting here, and I'm actually going to change this problem. I'm going to make it 36 million square Bryans. So what's going on is I buy this house. It's 36 million square Bryans. I want to know how many square feet this thing is. And all that you know is that there are 73, a Bryan is 73 inches long. In other words, 73 inches equals 1 Bryan. Fine. So a couple different ways you can solve this problem. Option 1, the idea here is to kind of convert into one-dimensional units. And so what I mean by that is all of my conversions between inches and Bryans and between inches and feet, what I know them is they're one-dimensional conversions. But this number is a two-dimensional number. So one way I can do this is I can think of 36 million Bryans squared as the area of a square with sides. The square root of this number is 6,000. So I have this square, and the sides of the square, one-dimensional, we're talking about length now, are 6,000 Bryans. And so if I could figure out how many feet that was, then I'd know the length in feet of the sides of this square, and I could then square that number to get the area of that square. So I'm taking this 6,000 Bryans, and what I'm trying to do is convert that into feet. And the way I'm going to do that is, well, I know that 73 inches is 1 Bryan. So when I multiply by 73 inches over 1 Bryan, I'm really multiplying by 1. I'm not changing the value of anything because the top here is the same as the bottom. And now I have my units in inches, but I don't want them in inches. I want them in feet. So I take advantage of the fact that 1 foot divided by 12 inches is also equal to 1, so I'm not changing any values. So if I multiply this through, I get 6,000 times 73 divided by 12, and I get 36,500. What that's saying is 6,000 Bryans is 36,500 feet. So the house, so the square that represents the house is 36,500 squared. So house area is 36,500 times 36,500, which is equal to, wow, a ridiculous number. All right, let me try to write this. There are 4 zeros at the end. Well, put the equal sign up here. 1, 2, 3, 4 zeros, and then before that there's a 2 and a 5, and then before that there is a 2 3s and a 2, and before that there's a 1. So 1,332,250,000 Bryans squared. Another way you could do this problem, if you're interested in another way, option 2 is to use two-dimensional conversions. So you start out with 36 million Bryans squared, and you multiply that by, well, how many Bryans squared are in a square inch? Well, there are 73 squared, which is 5,329. So 5,329 inches squared is 1 Bryan squared. And since there are 12 inches in a foot, there's 144 square inches in a square foot. So 1 square foot is 144 square inches. And if you multiply those all across, 36, 123 million times 5,329 divided by 144, should get the same answer. You do. You get this 1,332,250,000 Bryans squared. So a couple different ways to do the same problem. Whichever one makes more sense to you is what you should do. This last problem here, I have compound units. Okay, so for this next one, I'm driving 88 Bryans per second. How fast is that in miles per hour? Well, we can think about it as 88 Bryans over 1 second and do some conversion so that turns into miles per hour. Well, let's see, we can change Bryans into inches. And the way we do that is taking advantage of the fact that there's 73 inches in 1 Bryan. And then we change inches into feet by taking advantage of the fact that 1 foot is the same as 12 inches. And then finally, we can change feet into miles by saying that 1 mile is 5,280 feet. So our units here are now miles per second, which isn't what we want. We want miles per hour. So we change seconds into minutes by saying there are 60 seconds in 1 minute. And then we change minutes into hours by saying there are 60 minutes in 1 hour. And so I can go through and kind of double check my units here. The Bryans would cancel, the inches would cancel, the feet would cancel. So I'd be left in miles. And then the seconds would cancel and the minutes would cancel, so I'd be left with hours down on the bottom there. And so if I multiply across, I get 88 times 73 times 60 times 60 divided by, what do I have in the bottom? A 12 and a 5280. And I think I made this work out nicely. Let's see. I did. Cool. It's 365. 365 miles per hour. Pretty quick. Whew. And I guess that ends this quiz here.